Okay, let's try to get that out of there a little bit.
Okay, quick sort of introduction. All right, welcome everyone to the first competing seminar for the new year. Very excited, and especially that we're the first one I think that we've ever done in person as well. So let me know how that works out. So for today, Dr. Adam Gordon-Fennell from Stuber Lab will be talking about tips and tricks for coding and using Illustrator for generating high quality figures. So Adam, you can take it away.
Hello to everyone in the room and anyone who might be seeing this recording in the future. As Charles said, my name is Adam Gordon-Fennell. I'm a postdoc in the Stuber Lab. And today I'm going to be talking about some of the techniques that I found very useful for producing figures using code. Just to kind of highlight the problem that I'm hoping to help everyone solve is through the last talks that I've given, kind of gone over how to replace a kind of traditional, often paper-based, distributed form of analyzing data into something that is more of an automated pipeline. This alone makes a huge difference for making things easier on you in the lab and also more reproducible across experiments and also for tracking your work. But oftentimes, even when I've been able to persuade people to start using R to process all their data, they'll, instead of going straight to Illustrator, they'll instead introduce Prism or another plotting application at the last kind of step before moving into Illustrator to assemble the final figure. This has some of the problems that we've previously identified, where at the end of the day, there's always going to be some risk of copy and pasting errors. And this can result in like mismatching data. I've seen examples of this firsthand where we have a kind of figure at the end of the day, but we actually can't go back and trace where all those data points were coming from. And sometimes that can be a relatively insignificant problem, but sometimes it can be an extremely time-consuming problem to fix. And then also it's low in terms of its reproducibility. I mean, there are tricks that you can use in Prism to increase that, but at the end of the day, oftentimes it involves a lot of manual labor in order to get data into this figure quality format. But there are some major hurdles to using programming languages directly to then generate figures. The first is that when you're learning how to code in particular, but even after doing it for many years, it can take some time to produce your plots initially, much more so than it does with something like Prism. And then if you don't know kind of all of the parameters, your figures are often going to come out in relatively poor quality before you go in and do that work. And the last is that people find that it can be difficult just working on the Illustrator side of things. So just to kind of look at kind of what the final product is going to look like, I have this one pulled out of a recent paper that I published. The one important thing I always like to highlight up front, that's something that I think many graduate students don't understand before they've made their first paper, is that every journal will have really explicit requirements for kind of what features that these figures can have, including dimension requirements or text requirements, all sorts of things that need to be followed for the particular journal. So it's always good to start there. And they also have different requirements related to the formatting of the figures that have to get uploaded. So it's always good to check the journal prior to actually going through the process of building any of these. But all of these figures, despite the kind of differences required by the journals are kind of composed of similar things, which are actual data, as well as cartoons and pixel-based images with components drawn on top of it. And all of these need to be represented inside the vector-based software that you're going to use. The focus of today's talk is going to be on how to use programming language. I'm going to use examples from R to produce these components that are already kind of close to being the final quality. And then the second part of the talk is going to be how to take these components and then quickly assemble them into a final format that we have here. The kind of key is to try to get the plots produced by the programming language as close to what they're going to look like in the final component here. That will really trim down on the amount of time that you spend in this figure assembly. Before we get started, I just want to kind of ask, you're an undergraduate, right? Do you have experience with like making plots in programming languages at this point? And then have you made plots for Charles that are like destined for a paper yet?
Not destined for a paper, just I've made several plots.
Nice. Poster? That's good. Yeah, that's everything we talk about here will also apply to posters as well. And then for you guys, have you made figures for a paper yet? We've made posters, both of you. Okay. And then kind of what have you used R or Python for producing the plots for your posters?
I'm kind of at the stage where I like have code to like make the figures in R, but I have them like switching back to Prism.
Yeah.
It's like
Totally. Yeah, that's yeah, a really common experience. I definitely did that for my first paper too. And then are you around the same position?
I've used like your R code, but I haven't made my own. I've done that like, entirely.
Okay. Throughout this process, feel free, if there's anyone on Zoom, feel free to jump in and ask specific questions for what you're working on. But yeah, it's good to know where people are starting. And then does everyone have experience in Illustrator at all? Yeah. Okay, good. It's good to know that we don't have to start at the really basic stuff. So first, starting with visualization resources, there are 3 kind of resources I point people towards initially. There's a fantastic book online. These are all free online, made by Klaus Wilke that talks a lot about kind of a high level view of how to visualize data in ways that can communicate to your audience. For more the nuts and bolts side of things, there are 2 books primarily written for R that go into actual like really nitty gritty detail for how to manipulate every single component of your figures. One that I've recently started recommending is ChatGPT. This one has actually been quite useful even for a seasoned programmer. Oftentimes ChatGPT will be able to find answers quicker than you'll be able to get by sourcing some of these other resources. So I'm going to touch on building plots with layered grammar. In R, this is done with ggplot, which is an extremely popular plotting program in R. In Python, there's a kind of it feels like a wrapper, but it's a replication of ggplot called plot9. It doesn't quite get to everything that ggplot does, but it does have the layered grammar, which many people find useful when they're building plots. But everything I'm saying today can also apply to other plotting packages, but these are 2 that I recommend to beginners who are trying to learn how to plot. So for these layered graphics, or layered grammar, you start with a data frame, and then you map on components of your data frame as either your X or your Y, and then you assign a geom to that mapping. So in this case, we'll have our mapping be the dose on the X-axis and then the length on the Y-axis. And then we're going to assign a geom of a point, which is just going to convert these X and Y values into points as are shown here. You can add on additional mapping from there by just adding it to the kind of starting position that we had. In this case, we can map on something like color, which is now going to take those points and then color them based on this other variable in our data frame. And then you can just kind of work from there by just building up more and more components of your figures. In this case, we can put on summaries in the form of a mean and an error bar that get mapped on top of our data, all without touching our data frame here. One thing I do like to kind of stress is that you want to make sure that you understand the data frame going in, so you know what's being used for these means and standard errors, but this is a convenient way of not having to pre-process a lot of data. So the first thing you're going to want to do is adjust the theme. So the default theme in ggplot in particular is quite ugly. There are better defaults out there, like Seaborn I think has a better default, but regardless, with both ggplot and Seaborn, you can play with the theme to get it closer to what you want it to look like. In ggplot, this is done just by adding a theme component here at the end. And then in this case, we're using theme BW, black and white, which is one of the default themes coming from ggplot. And you completely change how the plot appears, even though the mapping is all the same. You can create your own custom themes. This is true in both Seaborn as well as R, but I think it's prevalent in other packages as well. These you can start by taking a default theme that's already present, and then you can update every single component that you want to then change, including the thicknesses of the axes, the default text size. All of those can be adjusted here. So this is really convenient because there's already packages out there that replicate Prism and stuff like that. But you can also go to your journal and then find the requirements for that journal, and then you can make sure that your theme fits the requirements for that journal. And then now when you apply it, you get something that I like, or closer to what I would like shown down here. And I highly recommend just taking this function and just saving it somewhere on your computer or on GitHub, and then you can just read it in every time. So you don't need to actually know what's written here. All you need to do is just read this as a function and then apply it later on. The next thing people often want to adjust is the color scale. So the default color scale is okay with ggplot, but oftentimes you're going to want to assign color that has some sort of meaning for you. There are a bunch of packages out there to do this. Viridis, Pals, Color Brewer. One that Madeline recently turned me on to is Met Brewer, which has really cool color scales. But all of these are applied to your data in pretty much the same way. So in this case, we have our plot where now we are using assigning color from the dose. And then if we want to change the color scale, all we have to do is add on to it the scale that we want to use. So in this case, this is a Viridis scale from that library. But you can also assign custom scales as well. So you can now just assign like gray, red, dark red directly to the plot that you'd already generated. And then similarly to like saving the function somewhere, you can save this scale somewhere on your computer that you're going to use for your whole paper. So that way you don't have to regenerate this again. You can just read it in. The next thing that I think Prism does really well that R does really poorly is default to adjust the axes. Let's just move this guy. So when we just do a standard plot, it looks like this. And there's these points on here where the tick lines don't line up with the corners of the plot. My old PI absolutely detested when this happened on plots. Would be unhappy if I give everyone like this. I don't know if your PIs find them as detestable as she did. But this can be easily changed by setting the limits manually, which now sets these positions here on the plot. And then by setting the expand to false, you'll then now get these hard edges between where the y-axis is and the tick marks. The next thing, and even if you disagree with everything I've said to this point, this is one thing I do think that's worth kind of incorporating to make your life a lot easier, which is specifying the dimensions of your plot at the point that you're generating it. So if we plot a standard plot here, the dimensions are set based on the entire plot. So this includes the text, this includes the legend. And so if we're trying to make our figures consistent in terms of their size, none of this will actually line up if you have different components to your plot. And in ggplot, this can be done using this forced panel size function from the ggh4x package. And then now we can actually set the dimensions in centimeters or inches within your plotting space itself. This is something that some of those plotting programs will do automatically for you, but here we have to do it for ourselves manually. This is really, really useful. And the reason why is that now at this point, when we import our plots into our figure, it's already scaled appropriately. So you're not wasting time having to scale your components and then have to redo your axes or like adjust the size of your font. It's already coming in exactly as you want it to look inside your figure. One of the last things I want to touch on is just the capacity of creating multi-panel plots prior to when you save them. This can be done using the library patchwork, which can then be used to programmatically assemble these multi-panel plots. This is useful if you are plotting the same thing many, many times across like different groups, for example, where you can now create your plot and then assemble it and set the dimensions prior to the point that you're saving it. So now when you rerun it, it'll already recreate, let's say, a whole row of your final plot. It's already aligned for you. Okay, so this is probably the most complicated part, which is going from this nice figure that we've created and then trying to convert it into a function. So this is kind of where the rubber hits the road for using a programming language to generate plots. So if we spend a lot of time getting this perfect to plot just the way we want to try to take advantage of that work that we've done and easily apply it to other data sets in the future. And so to do that, we're going to convert this plotting line of code into a function where now we can define components within the within our data frame to then generate these plots for other data sets. And this is kind of what it would look like on the output. We generate a function here that has all of the components to reference the variables within our data frame, as well as apply labels and limits to our plot. And then now we can call that for a different data set, in this case, the MT cars data set, where we can produce figures with the exact same dimensions, with the exact same aesthetics, without having to actually play with anything behind the scenes. So how this is done is relatively straightforward once you learn the syntax. The main thing we're trying to do is replace all the static elements with function arguments. So if we start here with our original lines of code for generating our plot, we have references to variables within our data frame. And we're going to want to replace those with something like this, which is calling the using what's called bang bang as name to now return the corresponding variable within your data frame. So now instead of referencing it directly, you'll provide a string that will then be used to reference in your data frame. And then there's other tricky kind of syntax that you have to pay attention to. And in general, I think the easiest way to do this is actually to use ChatGPT. For example, it found how to do this particular trick for me, which has been very useful. But you can also just pass it something like this whole thing and say you want to turn it into a function and then specify what you want to be replaced with these arguments. Before we move on, is this making sense to you guys, the process of this?
Yes, maybe. Is there an example you can give? I'm not familiar with like the.
Yeah, so this is definitely, this component is going to be very R specific. You can't pass in a string here. Let's say that we go back to our actual plotting function one. It could be a little bit hard to see on the screen, but if we just passed in, let's say var x, and we use the string of, where is it? Hold on, let me just check where var x is being passed to. Oh, right here. So right here, we're passing sup for our var x. If we just replace that with a string, it's not going to reference the variable within the data frame.
So you need to have that as kind of a function, access their function to convert it to the format.
Exactly. It's basically on the back end, it just makes it so instead of being processed as a string, it's then processed as a variable. This is probably pretty R specific. I imagine that there's like other ways you'd have to do it for the other programming languages. The other way to go around this is instead of defining all of our variables up here as strings, you can instead have hard-coded variable names, and then you just transform your data frame going into it. That's another way to do it. One reason why I prefer doing it this way is that it forces you to actually write out when you call it exactly what you want to use for these variables. So if you've made a mistake inside your data frame, that'll be made aware to you at this point.
This might have been. Is there such thing as dictionaries in R? And can you like put all of your parameters in the dictionary as one single variable and then just
Feed that in?
Yeah.
Yeah, there are dictionaries. It could work similar. Yeah.
Or
So you. I think it's going to be like your mileage may vary. I know some people really prefer using dictionaries and passing it as one. The one reason why I like this one is that you could easily do this as like a loop or something. You can pass in a vector of, I guess you could do it for dictionaries as well. But yeah, that's another way to do it. Absolutely. I like doing it this way just because you kind of see from here exactly for this one particular plot, it's going to produce exactly what you're feeding into it, but it could easily be done with the dictionary as well.
Because I have been kind of simple. It's like the arguments go on, just like goes on and on.
Yeah.
Both ways have like their own.
Yeah, I completely agree with that. So now going to saving the output. So we have our plot that we produced inside our programming language. You're going to want to save it as a PDF or some other sort of vector-based file format. You don't want to be saving it as a PNG or something else that's pixel based. This is really critical. If you're using ggplot, always use this like call here at the end where you set use dingbats equal to false. Otherwise, it will represent some objects within your plot, such as like circles or these data points, as text instead of being vectors. This was a issue that I ran into when I was trying to adjust some scatter plots. Okay, so after all of that, we have these individual components, these PDFs here that are saved. And then now we're going to then assemble them within Illustrator. One final note is how to kind of structure your folders. It's kind of outside the topic of the presentation, but I think it's important and something that people have asked me about when discussing this. I always recommend within your output, like your folder, that you have your final drafts of your figures. Always save with them with the exact same string, the data used to produce them. So here this is what we have published in the supplemental for our paper. We have this file name here, which corresponds to this figure, and then alongside it, we have the stats data here, and this is the exact data that was used to generate this plot. But then we also have the statistics that were ran on this data set saved next to the figure. And this can all be done programmatically, but this again goes to the reproducibility question, where if you pull this up later with some stars on it, you want to be able to actually go back and see what statistics were actually conducted on them and what their direct results were, as well as having access to the raw data in case you want to do some other sort of visualization or some other sort of analysis on it. Okay, so now we'll get into the Illustrator side of things. There's a lot of things that we're going to go over, and some of it's going to feel a little bit bullet pointed. But I do think that going through some of the basics might help people be able to assemble plots faster using Illustrator. The first kind of thing, and this might be a little bit too broad for this audience, is that there are two major types of visualization softwares. One is going to be vector-based and one's going to be pixel-based. There are both paid and free versions of these softwares. But the most common is going to be Illustrator in academia. I know that there's some floating around at the NAEP Center in certain labs. But there's also Affinity Designer, which is a lower cost one, and then Inkscape, which is a free one. The important thing is that under the hood, it's going to be representing objects as vectors rather than representing them as individual pixels.
Other options.
I've used Affinity Designer. It gets you about 90% of the way there to Illustrator, but it definitely doesn't give you the precision that Illustrator does. So I ended up going back to Illustrator. Inkscape does get you to like almost everything that Illustrator does, but the interface is really clunky in my experience. And after being trained in Illustrator, I found it really hard to try to learn Inkscape. But I know of people who love Inkscape and are able to use it as well as someone could use Illustrator. Affinity Design, I think, is great for like undergrads and people who are like making posters and stuff like that, where precision isn't quite as important. But I definitely prefer Illustrator at the end of the day. Even though I think a really old version of Illustrator is going to be better in my book compared to Affinity Designer. So when you create an Illustrator file, you're going to be able to set the dimensions of the figure or the space, I guess. And then you're going to be able to set the dimensions. I like to highlight this because it's usually best to kind of specify at the point that you're generating it, the size of the figure that you eventually want to make. So again, check those journal requirements here. I always recommend using artboards. Artboards are created using this tool here, where you can create individual plotting spaces all within one Illustrator file. These can be quickly navigated to using this navigation window here, or these arrows here, where you can kind of bring up each artboard one at a time. The major advantage of using artboards is that you can fit multiple figures, or if you have a relatively, like your data isn't really have high sampling, you can fit all the figures for your paper in one Illustrator document. And this will enable you to do batch editing without the need of doing any macros. You can instead just edit the components of all of your panels simultaneously. The only disadvantage that it could be slow with large file sizes. Just kind of show how this works for a real case. This is the last figure of the orbits paper, and we have artboards for the main figure as well as all the supplementals, all within one Illustrator file. I found this much easier to navigate than having like 20 independent files at the end of the day. And then you can export artboards individually, or you can export the whole thing as one large image, which again is easier than having to do batch export through macros. So now we'll get into kind of what I think is the most important part of this part of the talk, which is importing figure components. There's two ways to import figures. One is embedding and one is linking. How do you guys all embed, like bring in your figures? Do you bring them in as like individual vector components, or do you link them?
I just drag them in.
So you embed. Do you guys embed too?
It's like open with Illustrator.
Okay, so that's probably embedding. This is a trick that I learned recently, and it's got me really excited. So typically if you're embedding, you're going to drag it into this top row here, or you'll open it into independently, and then you'll copy over the components into your main figure. This is going to have all of the elements already like in vector format within your figure. If you can edit these, then you know that you've embedded it. This has the advantage of making it so you know exactly what's in your figure. It's never going to change. You aren't on the risk of breaking your links. But there are some huge advantages to linking that I want to try to highlight. So instead, with linking, you will drag your your PDF that you care about directly into your artboard. And what this is going to do is going to import it as a linked file, which will have this like X over it to indicate that it's been linked. This is not the actual vector components. Instead, it's just a representation of this PDF file within your artboard. From there, you can create a mask where you actually draw over the plotting area you care about, a square, for example, and then you click Make Clipping Mask. And then now you have this small component, just like you would if you copy and pasted and embedded. So the huge advantage of linked files is that you can do all the work of building your figure, but if they're linked, then when you update the original PDF, let's say we decide we want to change the color for all of our components, and then you rerun it, now the Illustrator will give you a notification that you need to update the links within your figure. And then now it'll automatically update all of the panels within the figure, within the Illustrator file. The other huge advantage to this is that you can build these figures before you have your whole data set as well. And then when you update it with additional subjects later, you don't need to recreate all of your figures and import them and edit them. Instead, you can just update the link and then it'll automatically fill in with the new and most current data. It blew my mind too.
So when you make the clipping mask,
Uh-huh.
then it gets, that's effectively embedding it, but then maintaining the link.
Yeah, so you make the clipping mask in order just to be able to like move it around and interact with it in a way that's like easy to do so. But the advantage here is that so long as you've specified the dimensions correctly, then when you update your panel, everything will remain in place. The final step is always to embed it, because you want to, at the end of the day, be able to, if you need to, edit these individual components before like publishing the figure. So to embed it, all you have to do is go to this links window here. So under window links, and then you can embed your all of the components within your figure. And then now it actually becomes the vectors that they would be otherwise. And then now they're editable directly. The other thing you can do with linked files too, which I haven't worked with in the past, is you can go to the raw PDF and then directly edit it, and it'll update it in your main figure. The only advantage I see there is that if you are using this for, let's say, a poster and for a paper, you can just edit it once and it'll appear in the others. But even if you're just using it for assembling a single figure, like the linking does really help if you are not in the very final stages of your plot creation. For example, I have a paper, or I have a result now that I've been working on. I'm pretty sure it's going to, like, we already know what the figure is going to look like. Even though we're still doing some cell counting, I've like generated the whole figure for it. And it's just a matter of rerunning it once we have the full cell count. So I can bring that up now. Where's Illustrator? So if I bring up the one that we're working on, so it's right here. So we're doing a tracing study and we're doing some cell counting. And on the first day where we collected the images, as the rotation student in the lab is working on the cell counting, I was able to generate this figure, including having the data plot over here. But this is actually linked. So if I double click on it and go to the linked file, hold on. I can double click on it here and then navigate to it, and it'll open up where the file is actually located. And now if I edited this here, it would be reflected over here. But more importantly, if I reran it now with more data points, more like subjects, or like now like the final values, it'll just automatically update this component. So I don't need to go through the work of reassembling the plot at any point. Is that making sense to everyone? And kind of is the advantage clear as well? Because this way it's like, I can't tell you how many times I have had to go back and rebuild these figures pretty much from scratch after we decided on, let's say like we add an animal or remove a single animal. Now you'd have to go back and regenerate every single component of your entire figure, bring it into Illustrator, and then do the same kind of steps that you did previously. But now, because you've just linked everything, you change that, remove that subject, you add in another cohort, you just rerun it, and your whole figure just updates.
That works primarily because you've already done a lot of the formatting.
Exactly. That's why when we got to the overview, let me pull that up. It's absolutely crucial that these are in as close to your final draft state as possible. if you're doing a lot of editing, and like that editing, no matter what, you're going to have to do some of it. But if you're doing a lot of like hand or manual manipulation, then yeah, this linking will not work for you.
Because like once you rerun it, it's gonna kind of, it is gonna default to like what the code is gonna spit out, which is like in that place.
Exactly. Whatever
So-
that file is, that new file is, that's just going to be reflected in your Illustrator file.
Gotcha. Okay,
So-
so it's not gonna save any Illustrator related changes, to clarify.
Exactly. Yeah. So you would have to, yeah. And if you want to be really careful and you're worried about breaking links or something, you could always save an embedded version of it. But yeah, it's not going to remember. It's not going to have like track changes for manipulation of objects or something like that. That could automatically be reflected. That unfortunately doesn't exist as far as I'm aware. Yeah.
You have a message in your chat.
Okay, so we have gotten to the embedding. Let me pull this up. So now that you have your embedded components, the next thing we're going to do is actually assemble it. There are a couple of tricks. Sorry. There's a couple of useful tricks that I've come across that make this whole process so much easier. And I just want to highlight them. One is called matrix view. This one, you have your standard Illustrator view, and then you press Control Y, and then it makes your image into a black and white image where it's only showing you the vector-based objects within your image. This is extremely useful when we start talking about aligning and stuff like that. It's also useful for identifying all the components of your artwork and then being able to like select and remove individual components when it can be very tricky doing that when you don't see like how these individual objects are overlapped with one another. The other general trick that is extremely useful is grouping and isolation. Grouping works similar. I'm sure everyone's seen it in PowerPoint and stuff like that, where you can select a group of components and then group using Control-Shift-G. And then now whenever we modify, like let's say the height, it'll modify the height of everything together. So if you need to adjust the size of something and you have your scale bar over here, you can just group it all together and then scale it. And so you're scaling your data at the same exact ratio that you're scaling your scale bar. So that's really useful. The second component, which is a little bit less familiar, I think, for most people, is isolation. So with isolation, you are starting with a group, and then when you double click on it, Illustrator basically ignores everything else inside your document except for what's isolated. So this is extremely useful because we're going to talk about batch manipulations later and selection, batch selection. The isolation is going to make it so it's only going to perform those actions within the isolated group. Okay, so now getting to like the nuts and bolts of how to like actually organize everything in a way quickly. The first kind of, yeah. Okay, thanks. So I think we'll be able to go through the rest of this pretty quickly. The first is ruler and guides. So using Control R or going to view and then going to rulers, it'll pull out these rulers on your Illustrator file. And then by turning on guides, also within view down to guides, you can now click on the ruler and pull into your field of view these blue guides here. So these are not objects within your image. They're just used there to help you organize your plot. You can lock the guides so you don't like manipulate them, and then you can also just hide them by using Control semicolon again. So during the figure construction, it's often easy to kind of bring out all these guides first, which will help you position all these plots quite quickly using that matrix mode. and zooming really far in onto your image. It'll allow you to kind of get the lattice that we want to achieve. The next, is everyone like familiar with alignment and distribution tools? No, okay, I'll go over them quickly. So this is a useful tool after you have many objects. You can select them all, and then over here on the right side in the properties section, there are some tools that are here in the align section, and these will change the position of all of the objects in some organized fashions. The first is you can align by top, which will now align everything by the top of the component. And they can also do distribute. So this one here is distribute center, and now it's organized all the components so they're equally spaced from left to right. This is extremely useful for all sorts of aspects of figure construction. Just to highlight one of the examples, it's really useful for fixing axes. So you can just adjust one edge and then the other edge, and then from there align by center, and all of them will be aligned at the tick marks correctly. One other thing that I like to highlight with that helps organization is constrained movement. So if you just click on an object and move it around, it'll move around freely. But if you hold shift, it'll force it to be on either a right angle or at 45 degrees. This is again useful for if you have to duplicate something and then move it along a single axis. So that way you don't have to realign everything after creating these new objects. Another way to really precisely position components is to go to the properties, and then you can actually set the position within the artboard for the component relative to the relative point set here, whether it's the center or the top left or top or bottom left or whatever. You can then adjust these either manually by putting in an exact position, or you can actually put in math here as well. So if you want to make a component half as tall, you can do divided by 2, or you can make something half as wide, or like position something relative to another component by using addition or subtraction here. This is really useful if you want to get extremely precise with the location. Okay, the last thing I want to touch on is batch modification. I'm glad we had time for this. Batch modification can also save you a vast amount of time. It starts by selecting a component that you might want to edit. Let's say you want to change the axes, the line thickness for all of the axes throughout your entire paper. If you set the stroke on your axis to something that's unique, you can go to select same stroke weight, and then every single stroke on the entire document that matches that stroke width will now be selected. And then now you can edit the stroke here, and then you'll automatically change all of those components across all the ones that you had selected. This can also be used for other objects as well. For example, if I group and isolate the scatter plot of the paper and we select one of the dots, let's say we want to make the dots larger, we can go to first select based on appearance, and then we can go to object, transform each, and then we can modify each one of these individually relative to their own position, allowing you to scale it without having to go back to your programming language. Again, I think in general, it's better to do this from the programming language, but if you get to the point that you're ready to publish, you just need to do this modification to make it perfect, it can be done using these batch selection tools. Okay, so I hope everyone understands kind of like a way to do this, to build figures a little bit more quickly. The key is consistent scaled plots produced hopefully using functions from your programming language, and then linking those plots and organizing them in Illustrator, and then applying bulk modification. And hopefully using these tools, we can help cut out the prism component and make our lives a little bit easier. All right. Thank you. If anyone has questions, I'd be happy to answer. I'm conscientious of the time, but I'd be happy to stick around and chat for a little bit. All right, well, yeah.
So hear me. So one thing that sometimes comes up, and like I had a huge pain dealing with, is exporting. So once you have your figure done in Illustrator, exporting it and then loading into like Word or something, and not have the quality degrade on.
Yeah.
I have some like guidelines, like processes that I have written down, so I can dig it up, but there's something that is like kind of tried and true that you have.
Yeah, I've definitely noticed that as well. What I usually recommend for the actual final export is, so let's say we want to export, I don't have other artboards here, but let's pretend I have other artboards here, each with their own components. The final export I usually do through File and then Export As. And then here you can specify the type that you want to export as. So say JPEG. And then you toggle this Use Artboards, and it'll export each of these individual artboards as a separate JPEG. And then you'll want to set on here your resolution to be high. Or go to custom and then do a resolution of like 600 ppi is usually enough to get like really high quality images into like Word documents. Is that usually the way that you did it, Charles?
I think also to do something where you like there's a setting for like the saving function that you have to specify that needs to save as high quality as possible.
Yes, yeah, absolutely. If you need to save your final Word document, you also need to specify the DPI there. Or the
And then on top of that, if you want to export that as the PDF, then you also need to do some
yeah.
similar manglings.
Yeah, I highly recommend exporting as a JPEG and then importing that into Word rather than trying to work with a PDF in Word. I've had nothing but trouble getting that to work.
Maybe I'll try that next time, because what I thought would work is to import your figure in as a vectorized format into Word and have Word figure that out, but it seems
I find it easier the other direction. So using the Illustrator to then generate the figure at the right dimensions with the right PPI, and then just dealing it with Word as pixels. That has, for me, has been much more reliable. Because I ran into the problem that you had. It's Word saving vector-based images can be really problematic.
Hi, can I ask a
All
question?
right, thanks everyone. Oh,
Can you hear me?
I can't hear you. Oh, hold on.
Yes, I will
Can you
change.
turn on your volume?
let's see if I can get my
Charles is turning on his speaker.
okay.
Okay, we can hear you now.
Yeah. When I was doing some Illustrator work, I always feel difficulty choosing the color for like good contrast between different group and how to select the color. And do you have some tips to select which color is the most high contrast and like looks for the reader?
Yeah. So I personally, I love the Viridis package. In general, I'll just try to stick with that. If whatever my groups are like ordered in some way, I try to use the Viridis package, and you can pull out set values from there. MetBrewer has some really beautiful ones. Another one that I've really enjoyed is there's a program called Color Picker online. It's like an HTML color picker, and you can put into that the color that you're going to start with, and then it'll help you pick contrasting colors or similar colors from there. There's a few different ones of these online, but this one has been great. I've really enjoyed this one. It'll give you like either complementary colors down here or analogous colors. These have been really useful. And then the nice thing about having it already in hex is that you can take that hex value here and then just drop it directly into your Illustrator file. It's not sharing. It's popping up on the, hold on. Let me pull it up over here. Can you see my screen now?
Actually still not, I think.
Here we go.
Yes, now I can
The
see.
color picker is right here. Where you put in a color that you want. So let's say we're starting with a green color. And then when you scroll down, you can select different options. So you can get complementary colors or 4 colors or 3 colors. And then you can adjust this one on here and it'll automatically get a set of colors at the bottom. This one works quite well. And then the nice thing about having it be in hex is that once you grab this hex number, you can just put that directly into your Illustrator file. For some reason, the Illustrator is not coming up on here. But this is a convenient way of really quickly selecting the exact color that you want in Illustrator.
Thank you very much.
Make sure that the color you use is very precise, so that way, if you have to go and edit it later, you can batch select by the color and then edit it that way, rather than having to like have to go click on a bunch of different things that are closely matched in color but not actually the same.
Yeah, thank you very much.
Yeah, thanks, Dan. Yeah, see you everyone else next time. Thanks, everyone.